Intervals are of two kinds: open, closed. The open interval is represented by this symbol. This closed interval is represented by the square. This is the ordinary brace, this is the square. And there can be, of course, the right open, or you can have left open. It's up to you if you want to use those notations, if you can use those notations. But basically, what they mean is this. Hello. So, uh, 3, 2, 3, 2, 2, 6. 2, 3, 4, 6. That's it. This is the x-axis, y-axis, domain, codomain, now how closed and open intervals are. Let's say do one. One, two, three, four, one, two, three, four, minus 5, 6, minus 5, 5, 6. So, we'll suppose there's a function like so. What are the values of the x and y here? Here x is 3.5 minus 3.5. Here it is minus 2.5. The negative part of x, positive part of x is plus 5. Positive part of y is plus 2. Now, if there is a function like this, which is open at this end and closed at this end, so what does it mean? This is open. Open interval does not include these values. In the sense, here 3.5, here minus 2.5. X cannot take 3.5. How x can be expressed in the as an inequality? How can we express this? What do you call range? No, not range. We would say domain of definition. How can we express it as an inequality? Minus 3.5 less than x less than plus. Meaning x can take values up to minus 3.5, excluding this one. This is not 3.5, it cannot take because it is an open interval. Whereas closed interval takes the value of 5 to here. So it can be equal to 5 also. So as an inequality, this function can the x values of this function, the values of this function argument can range from little above 3 point, little bit above 3 point, right? And up to 5. Because here here it is open, here it is closed. Similarly, let us look at y. What values y can y take? Y can take minus 3.5. No, this should have been 2. That should have been 2. That should have been 2.5. Here 3.5 less than y. Again, this is open interval. So this is fine. So far it is fine. This is closed interval. And here, what value we took? This is 1 plus 2. This is more than plus 2. 2.5 plus 2.5 because it lies between 2 and 3 here. This point. So that will be less than or equal to plus 2. So I hope the concept of open interval, closed interval is you understood that. And mathematically, how can we express this? X is as in set notation, right? AB, X belongs to R. Of course, these are Cartesian coordinates. So they are all subsets of real numbers, set of real numbers. So X belongs to R such that, as we have already seen here, minus 2.5 is A. Let's say this is A, this is B, right? So A is less than X, less than B. Right? Why? Here, because this is open interval. This is open interval. So let us say it extends to minus infinity here, plus infinity here, right? Then let us say, how would this part from here to here, how would it look like? Let us say you have an interval like this, B. X belongs to R again, such that X is less than B. Because this is we can take values from minus interval and it is closing at B. Here, it is closing at B. This is a closed interval between minus infinity and B. So this X, what values of X can take? Minus infinity to B, but excluding these two. That is, X is less than B, right? It cannot be B. Here you cannot have equal sign there, less than or equal, because X is less than B. Because this is a we call that's an open interval, does not include B. Alright, now next let us go to A plus infinity is equal to X such that X belongs to R such that X is rather here it will invert. A is less than X. A is less than X because plus infinity X can take values up to plus infinity, and the least it can take is A, but not A itself, or plus infinity itself. So it belongs to the real set such that x is a is less than x. From a to infinity, it will take, but this it will not take a or b. Okay? Open it. So the other world will be naturally minus infinity to minus infinity, meaning x belongs to R, minus infinity to infinity. So what would it be? What are we left with here? If you take off minus infinity plus infinity here, what do we have from here to here? That is the set of real numbers itself. So that is equals to R itself. We don't even need this because there is no inequality here. That the infinite set. There is no inequality there. The whole real number set of real numbers values extended. Okay. So now we go to closed interval. Closed interval, as I told you, let's say here, this is open, this is closed. So in closed interval, the notation is a square bracket a, b square bracket. So how can we express this as we have already seen here? The only difference would be this equals. So is equal to a set x belonging to R such that a is less than x and a is less than x less than or equal to b. Both ways actually here you have to take equal sign also. If you take a closed interval, x can take value a, b also, apart from the range between the number between. Or the other way to represent a closed interval, close we have covered. Now we can have what we call a combination of these two. Combination of closed and open and closed. So you can have left open A, B, right closed. That would be what values x can take then. B, right? Of course, set notation. In set notation, it would be all the x that belong to real numbers, satisfying the condition x a is less than x less than is equal to b, because here b also it can take, not up to b, but b also it can take. On the other hand, let's say the very opposite of this. What would it be? It will be square bracket a, b, ordinary place. That will be x belonging to R such that A is less than or equal to X less than B. Here, this is the closed one. In closed one, it can take value A also, right? But for B, it can because it's closed. What are other notations we can have? We can have, let's say, uh, plus infinity. That will be like in this end it is closed. Both ends. Let us keep it open here. So what will this be? Naturally, x real number. It belongs to real numbers such that A is less than or equal to X, because here it can take A also up to plus infinity. So you need not mention the other part here. The open part you will not mention here. Okay. Anyway, this equation inequality represents the whole set up to infinity. And then we have B, and this is square. So this is open, this is closed. So this is closed means x belonging to R such that minus infinity x b x we have to reverse it here. Yeah, so x is up to b it can take less than b, but since it is a closed interval, we can take equal intervals. That is how we can represent the open closed intervals. And then there's one more thing I will mention. It's about notation. Notation can be the open for open. I told you for open is represented by this symbol. This can as well be represented by this. Meaning this is what is the close symbol? Close symbol is this one. Close. Right? It is open, this is closed, and this is almost this like it is reversed here. This is again open. Open can be expressed both. Either you can represent it like this, or you can represent it like this. Yeah.